Hello everyone, Mr. Stevens here. What we're going to be talking about today is similar triangles. In the previous lesson we looked at similar figures and scale factors. What we're going to be talking about today though is how can we use information that we're given to test if two triangles are similar to each other. And then once we know that they're similar, we'll use all the things that we learnt about in our last lesson to calculate unknowns. So what we're going to start off with is how do we write similarity? Once we've proven that two triangles are similar, what are we going to be doing with that? And this statement here is the one that we need to learn. Okay, the three vertical lines there mean is similar to. So the way you read this statement here in the box is triangle ABC is similar to triangle DEF. And yeah, this last point is really important. Sorry, the letters are usually written in the order of the angles that match. So angle A matches angle D, angle B matches angle E, angle C matches angle F. Alright, let's talk about how we can test if a triangle is similar. Remember, what it means for a triangle to be similar is that all the angles are exactly the same and all of the sides are in proportion to each other. So for instance, in these two triangles, all of the side pairs are from the smaller triangle to the larger triangle doubling. So this is a valid test for similarity. If all three if you know the lengths of all the sides of both triangles and you can clearly see that they all have the same ratio, this is a good way to check it. Take the larger side and divide it by the shorter side, and then just do that for all of them. And each time you should get the same number as your answer. And then in that case, we could say that these two triangles are similar because we have three sides in proportion. If you were answering this question, that would be the reason that you would put in brackets. Okay, next one. If we have two sides in proportion and the angle in between them is the same, we can say that the two triangles are similar. So when you're testing if the two sides are in proportion, do the same thing. Take the larger side and divide it by the corresponding smaller side. And in both cases here, the answer is 2. And then if you know that the angle in between them has the exact same value, you can say that the two triangles are similar because you have two sides in proportion and the included angle. This word here, included, is an important part of this test because it has to be the angle that's in between the two sides. Alright, if it was one of these angles, this test would not apply. Okay. Here's another one. This one is kind of obvious. One of the criteria we said that makes shapes similar is if all the angles are the same. So this is a fairly straightforward one. If all the angles in the triangle are the same, then the triangles are similar. And remember, because we know that the angle sum of a triangle has to be 180, we actually only need to know two of the angles are the same. Because if two of the angles are the same, then the third one has to be the same. That's what this line here is saying. So if you were using this one to answer a question, you would say something like two equal angles. Right. And I believe this is the last one. This is a special one for right angle triangles. If you have the right angle and the hypotenuse is in proportion, and either one of the other two pairs of sides, in this case it's this side, but if we had a number here and here, that would be equally valid. But in this case we have the hypotenuse is in proportion and one pair of other sides is in proportion. So you say something like hypotenuse and shorter side in proportion. Alright, let's take these 4 tests now and apply them to some triangles. So this first one should be pretty obvious. The triangles are similar because we have 2 equal angles. In part B, we have a right angle triangle, so that should clue us into the fact that it's the special right angle rule. And we check here 9/3. The hypotenuse is in proportion with the other side, 6/2. Both of those things equal 3, so we're all good here to say hypotenuse and short side in proportion. Now, looking at part C, let's check the sides are in proportion. And yes, they are. Again, in both cases, that's 3. And now we're being told that the angle in between the sides is the same. So the test that we're using here is 2 sides in proportion and included angle equal. Sorry, my writing is a bit messy. Alright, part D, we're given 3 sides. So let's check them. The long side, now I think these are the pairs that go together. And yeah, they're all in proportion, so 3 sides in proportion. Okay. So this is kind of more like the questions you're going to be answering. So let's give a reason why these 2 triangles are similar. We have a side here and a side AE and a side BD. We also have... Okay, let's start with some angles actually. This angle down the bottom here is common. And we're told that these 2 lines are parallel here. So that tells us that these 2 angles are equal. And these 2 angles are also equal. If you remember back to parallel lines, those are corresponding angles between parallel lines. So we would say here, for part A, triangle, triangle ECA, that's the big one, is similar to triangle DCB. Now let's find the scale factor Let's take the larger side and divide it by the smaller side of the two sides that we know are in proportion. And we're going to get a scale factor of 1.5. So that means if our scale factor is 1.5 and we want to find x here, we need to multiply our shorter side by our scale factor. So that means x is going to be 7.5. Alright, and that's what you guys are going to be working on today. If you go to the lesson on iLearn, you'll see the questions I want you to complete. Thanks, guys.